Okay, in this video we are going to see how to apply this. What does this all mean? Okay, this is going to be a video for an example. It's just going to be a quick one. What we're going to do is we're going to prove that in a month, we're going to see that in a month the sun lags by approximately 2 hours sidereal time behind a star. You saw that in a day the sun was lagging by 4 minutes, because when I said the sun is tired, if you remember well here, when I said the sun is tired, it was lagging by 4 minutes. But you want to see that in a month that is going to add up to 4 minutes. That is going to add up to 2 hours. It makes sense, isn't it? Because we're considering a month that is made up of 30 days. In one day, sun lags by 4 minutes sidereal time. What about in 30 days? In 30 days, then definitely it's going to lag by 30 times 4 minutes sidereal time, because every day it's going to add 4 minutes. 4 minutes, 4 minutes, 4 minutes. So if we do that, this one is equal to 120 minutes sidereal time, which is approximately 2 hours sidereal time. I think this one was easy to see because every day it lags by, the sun lags by 4 minutes sidereal time. Therefore, in 30 days, those days are going to accumulate until it's a total of 120 minutes, and then that is what? That is 2 hours sidereal time. So basically, imagine on March. Now to apply this to what we will be doing on March 22. On March 22, what is going to happen on March 22? On March 22, we said at noon. On March 22 at noon, if you look up the sky and you see where the sun is, that is where you start your what? That is when you start your sidereal clock. So which means on March 22, solar noon will give us 0 hours sidereal time. That's what it basically means. Solar moon gives us 0 hours to sidereal time, because we said on March 22 or at noon, that's when the sidereal clock starts. So here, can you see? It will be this situation on March 22. V is in upper transit. V and A and the sun, they are coinciding perfectly like that. But as days go by, the sun lags by 2 minutes. It lags by 4 minutes every day. 4 minutes every day. 4 minutes every day. Therefore, now March 23. The day after that, V crosses. So V is in upper transit at what? At 11:56 p.m. because it's faster than the sun. So this one will be what? In upper transit at 11:56 p.m. So this basically means, what this basically means is, the sun has lagged by what? By 4 minutes. The sun has lagged by 4 minutes. So let's look at April 21, not April 22. April 21, the solar noon. What is the solar noon doing? Okay, April 21, the solar noon. What happens? What happens now to sidereal time? We know that sidereal time, it is basically gaining by 4 minutes, because it's ahead by 4 minutes every day. The sidereal time is ahead by 4 minutes, because here you can see on March 22 the solar noon was equal to 11:50. The solar noon here was now equal to 4 minutes sidereal time, because on the sidereal clock it is running faster than this. I hope you understand. The sun, when it's now in upper transit again, on the sidereal clock, it is now 4 minutes up. 4 minutes after after what? After. Okay. So this one will be 4 minutes. So when here it's March 22, and we have our solar noon, well and fine. Here our sidereal clock will be 0 hours, because our V will also be in upper transit, will be in 0 hours. But let's go to March 23. March 23, the day after that. And then we'll be like, yes, this is solar noon, because what? because the sun is in upper transit. But can you see that this V now, this V is now 4 minutes ahead of its upper transit, which means on the sidereal clock, solar noon is now coinciding with 4 minutes sidereal time. Can you see that? Initially, it was, on March 22, it was coinciding with 0 hours. But now, on March 23, a day after that, it's now coinciding with 4 minutes sidereal time. So that's what happens. In the next day, the noon will be coinciding with 8 minutes, because this one will gain another 4 minutes per day, another 4 minutes per day, another 4 minutes per day. So now, if we are going to move to April 22, April 21, after 30 days, we have, yes, our solar moon. This is not the diagram. This is not the diagram for this part that I'm talking about. I'm talking about the same diagram that is basically like this, because the solar moon will remain the solar moon. But then, what happens to our sidereal clock? Our sidereal clock was gaining 4 minutes every day. So which means on our sidereal clock, we will now have 2 hours sidereal time. So which means our solar time now is coinciding with 2 hours on the sidereal clock. That's basically what this now means. So this one now on the side, it will be 2 hours sidereal time. So that's what happens on April 21. The solar noon will now coincide with 2 hours sidereal time, 30 days later. On this day, V will have transited the celestial meridian at 10 a.m. What we're basically saying is 4 hours ahead. Remember, when it was 4 minutes ahead in a day, it means V crossed at 11:56. When it gained another 4 minutes, it means V crossed at 11:52. So what about in 2 hours? It means V is long past because sidereal time measures how far V is from what? From celestial meridian. So if V is 2 hours above celestial meridian, and we are considering celestial meridian at 12 hours, at 12 noon, it basically means V was there, or was in upper transit, or at the celestial meridian at 10 a.m. Then V ran 2 hours ahead, When the sun now came to celestial meridian at 12 noon, V was 2 hours ahead already. And on our clocks, we'll see 12 noon, but V, on their clock, they're already 2 hours ahead. So which means on our clocks, when we're still in class, or when we're still at break time, eating our breakfast, V was already what? Crossing at 10 a.m. was already crossing the celestial meridian. And we are going to discuss this further when you do examples. This concept is going to come up again and again when you are doing examples. And I hope you understand the concept. This is just the theory section. When you're doing examples, you are going to understand this further. So let's move on with the theory, and then we'll do the examples, more solid examples later.